So, hi everybody, I'm Anniina Korpinen from Finnish Meteorological Institute, and today I'm having this, weather briefing part of our meeting here. So, let's see. Okay, good. Because this is my second time I'm having this weather brief in this EUMeTrain. Few things about me. So I have been working in the Finnish Meteorological Institute for about 6 years now. I'm working now as weather forecaster, but I have been doing it since last autumn, so that's a quite new part of my career. And also I'm working as a meteorological expert. I'm doing this kind of numerical post-processing methods and working with the meteorological data. I have also previously worked as a researcher and a software developer, so I've been doing all kind of stuff in FMI. And basically everything more or less is always being involved, like validation of numerical weather prediction and working with the numerical weather prediction data. So maybe you can already see that I'm quite interested with the data and data science, and I see huge potential in its application in the field of meteorology and forecasting, and that's where I'm heading with my career now, more or less. Yeah, today's topics. First, the main topic is, of course, for me, the first part, the current weather conditions in Europe today, and then if I have time, probably I won't have time, I will shortly tell you about the coming up weather for Friday or Saturday. I think maybe for Saturday it's better because probably you all are having a holiday during that day, except for me. I'm having a work day Saturday. And after me, we have Petteri presenting a showcase of the storm Ahti. Okay, this is I think a really fun part of this meeting that we can mark where we are from, and I'm also put this like title part here that you can also mark where you are, what you are basically doing. So use the pen and then put where you are from and what you are doing. So I'm from Finland and I'm forecaster, but also the other. I love the other part, like it can be anything. It's not tells you nothing. It's wonderful. Yeah, we are going to have starting to have these marks all over the Europe. So we have Scotland and is that Wales rather than England? Maybe. Sorry about my geography, it's not great. And then we have Portugal, we have Austria, Croatia, Estonia, and then I don't know, is it Austria or Slovakia, but still. All over the Europe, really nice. I'm cleaning these all now, and let's continue. Okay. I need to stop the pencil.
Yeah, just close the annotation.
Yeah, no, okay. Yeah, let's get the main topic about the weather condition. Now we have the satellite product, which is more or less visible light. And at least I do use this to identify clouds and what sort of clouds we have. In northern part of the Europe, we have this quite wide cloudy area, but it's different from this Atlantic cloud that we have actually some convection in the most of the parts. So it's not only total cloud cover with precipitation. We have a brighter spot also time to time here. We have some high level clouds also, and then we have this bigger cloud also in here. Similar kind of feature we have this like in Baltic countries. So strong convection, probably strong precipitation. With that, there is this wider cloud area in the eastern part. In the southern part, we have these quite strong and wide, maybe mesoscale cloud areas, precipitation probably. In the Alps, we have also convection there. There might be also some snow cover there. It's really hard with this product to make different with the snow and this like low level clouds, which are both yellow. The higher level clouds are this with the eyes are these blue ones. In the UK, there is also quite strong cloud cover there, and then in the Spain Andalusia area, there is this strong convection happening there today. Yeah, let's see. Now we have also this 500 hectopascal geopotential height from the EC with this figure, and we can see that there's quite the European weather is quite divided. We have this really strong ridge here, which is affecting most part of the European weather, and then we have this really strong throat, which is affecting mostly our weather in here, Finland and Estonia and Sweden, so Scandinavia, northern part of Europe. And then there is this smaller event going on in the UK, where there's this smaller throat influence in the weather. Okay. Here we have this 24-day microphysical, which is basically a classification product. We can estimate, actually, you probably can't see my mouse here. That's probably the case.
We can see it.
Okay, good. I didn't even think about it. Yeah, with the red areas, there is the cloud, which have a bigger ice particle, or basically most only like ice particles. So they are also like, we can assume that the cloud top is quite high in here. With the red areas, there is this really strong convection going on in here, which is the smaller, really strong red spot. When we get from the red to a bit more yellow color, it means that we have more liquid droplets in the cloud. So these are like mid-phase clouds, quite thick still, but maybe lower level than the red ones are. And then we have this more like pure yellow ones, which assume that there's actually not that much ice particles at all, and the cloud itself is quite transparent, it's getting some light through, and it's quite shallow, so it's only low levels. And then we can see that there is actually, in the southern Europe, there is really not at all clouds. There is this really small, at least in this map, it seems like really small convection developing in the example in Italy and in Spain. It is probably causing some precipitation if it's developed a bit stronger what we have, for example, in this Central Europe part. Okay, and this is a capture from the EC. This kind of like a general weather. In the gray areas, we can see clouds or cloud cover, and in the bright colors, we can see precipitation areas. And it's actually, why I put it here, it actually fits quite nicely the satellite observations, what is the model also producing, which is always in point of numerical weather prediction really good. Very good to note that the rainy parts are more or less there where they should be. The Italy is really hard for the model. The convection is really hard for simulate for with numerical weather prediction models. Okay, and now we have here the water vapor channels. And what is outstanding here is this really dry area in the southern Europe. we can estimate that here we have a jet going on. Also in here and here. There is more moisture in this area. Also, it's not actually at moist that it's in Central Europe as it's in northern part of the Europe. And we now have also this 500 hectopascal geopotential height and then the 300 hectopascal wind speed, so maximum area of the wind, estimating the jet, and it's actually going quite nicely through whole Europe. So in the southern part we probably have quite warm air, and in the northern part we actually don't have that much warm. It's a bit cooler in the northern part or northern side of this jet area. And here we have the EUMeTrain satellite product, and what we can see and what actually have been probably almost all summer, that in the southern part of Europe we have this really dry upper level. So this area is really dry and it's also quite warm. In western part of the southern Europe there is actually also quite warm EUMeTrain, but it's much more moisture, so there's more moist in it. And in the northern part we have a bit cooler air, also with moist, and we can actually quite nicely see the cloud cover also in this from this figure. So we have like two worlds in the Europe. We have the northern part, totally different, and we have the southern part, which is also totally different compared to each other. Okay, and there's this 850 hectopascal temperature in this figure from the EASI today, and it's showing the same as the EUMeTrain satellite product was showing us, that we have a quite strong warm air in the southern part, and then we have these cooler areas in the northern part, and UK is somewhere between basically. Okay, now I've used my 15 minutes, but I think I will still show you about the Saturdays, coming up Saturday, what sort of weather we should have. And we can see that there is not going to be, with simulation, huge differences. So we have this northern part of the Europe, which are having the low pressure systems and precipitation and quite cloudy weather, same time as the dry weather is going to continue in the southern part, and they're going to have precipitation here and there, and this is quite strong precipitation area in the middle Europe is still living there and maybe moving a bit northward, so northern part of the mid Europe in the weekend. And if we check the EUMeTrain temperature, we can see that there is the biggest change is that the UK is getting warmer EUMeTrain also, so there's this warmer EUMeTrain moving to the east from west. The South Europe is still staying quite warm. There is no huge change in that, and there's also some warmer air coming from the south to the northern part, but we are still having this like a north colder EUMeTrain staying there and maybe moving a bit southern at some point. Let's see. So not huge changes coming up this weekend. Okay, that was my part. If you have some question, I actually don't see the chat. So if you have something, you can ask now, or we can continue forward and you can ask later on. Thank you.
We can check that later, the questions and comments.
Thank you,
Petteri, you can
Anniina.
continue.
Thanks. Okay, hey everybody, I'm Petteri Pyykko. I'm Anniina's colleague from FMI from the same group called Tailored Weather Services, and I'm going to present you this case from the last summer that we had up in northern Finland. I actually already presented some parts of it the last year, but now we have gathered some more material, and I was thinking that it would be exciting to at least some of you. So the instruments I'm going to be using here, they are VIRS, Severi, and IASI L2. And at least my favorite product is going to be the Cloudphase RGB that is produced by using the proxy data from VIRS. And it has two microphysical channels. The two first one that you can see there, the near infrared 1.6 and the near infrared 2.25. And they both provide information on the cloud top phase and the particle size distribution. And when they're used together, they yield information about the separation between the thick ice clouds and water clouds. And then there's the visible 0.67 channel for mainly cloud optical thickness. And then I also have the IR sandwich or some imagery from that. And then I use today Microphysics RGB and HRV Cloud imagery for some comparisons. Let's go for some imagery. So here is the pre-convective environment. The city of Oulu is denotated with the star. It's about 540, 550 kilometers to the north of Helsinki. And the area before the approaching cold front from the southwest was largely cloud-free in the morning. And the following ingredients are from the ECMWF model. So the air mass temperature was quite high for northern Finland, about 16, even 17, 18 degrees, if I remember correctly. The deep layer shear was up to 21 meters per second. Low level shear up to 15 meters per second, and the storm relative helicity was quite high to above 250. And that is conductive for even some isolated tornadoes and definitely some supercells. Also, the Cape was above 1,000, even 2,000 almost in some places, and the mixing ratios were also above 10 grams per kilogram. And this imagery is from METOP in the morning of the 21st of June the last year. Okay, now I probably need the laser pointer. So here is the IASI L2 sounding from the morning of the 21st. We took it because it was largely cloud-free, so that's when the IASI soundings work the best. And in the fields, in the background, you can see the EC values for the total column water vapor, and annotated with the dots or the circles, you can see the values from IASI. And as we can see here, these match up quite nicely with each other, apart from some details. And probably the most important one of them, or the most interesting one of them, is the area west of the city of Oulu that is now annotated with the triangle. And IASI suggests here that it's a bit more moist than the EC suggests, and this could have positively contributed to the formation of a MCS later in the afternoon or later in the day. I think it was around noon when it started. And here I just put this day microphysical from Severi, from the geostationary data next to the VIRS image on the right. And here, once again, you can see the city of Oulu with the triangle. And what can definitely be observed better are the cloud tops. Lower clouds are better visible. There's a better contrast in the VIRS image to the cloud-free areas. The single cells are to be observed better. It's almost like partially almost impossible to see the smallest single cells from the operational Severi data because the image is so coarse. And then the overshooting top features in the mesoscale convective systems are also visible in the VIRS image on the right-hand side. But unfortunately, the MTG imagery in the high latitudes will suffer from the high viewing angles, so that the MTG imagery that we're gonna get hopefully next year, it's not gonna be as sharp as the imagery here from VIRS in the high latitudes. So I tried to pull out this HRV picture here to illustrate like what we can expect from the capabilities of the MTG in the here in the northern latitudes. So this has the nominal resolution, or the HRV channel has the nominal resolution of one kilometer. So it would about look like this in the MTG imagery that will be available every 10 minutes from the FCI in the future then. And just for a comparison to the left one, the operational severity, day microphysical, it might be, or it will be easier to spot the single cells also if one looks closely at the HRV imagery and thinks that if it were some other products that has better contrast to the features depending on the cloud top height and temperature, so it might be, or it will be easier to see the overshooting tops over in these latitudes too. And here is the CloudPhase RGB. That is the new product. It is actually already available from the GOES satellites, but it will be new to Europe. And with it, I think it's quite easy to spot the overshooting tops. It has an even more distinguishable contrast to the cloud-free areas and the day microphysics imagery, at least in my opinion, and it might facilitate the tracking of single cells. And yeah, the color changes from dark blue to light blue depending on the height of the clouds and because of the particle size distribution. And here at last I have some imagery from well, the first one is actually simulated FCI using the VIRS data, but I have the IR sandwich imagery, and this one shows the developing thunderstorm, developing supercell actually that struck the city of Oulu about 1.5 hours, 1.5 hours later, producing a gust of like 30 meters per second. That's about 110 kilometers per hour. And here the higher and the colder cloud tops appear yellow to orange and red. And here in the we have this color enhanced infrared channel 10.8, and in the background we have the HRV channel for cloud top structures and cloud formations. But I think that the most important feature of this channel is of course the infrared channel that's for the cloud top temperatures. And this has this FCI simulated IR sandwich image is quite a big improvement in comparison to the currently operational severity image that you can see here. So if these cells were even a bit smaller, it would be hard to talk about the severity. Even with this image, it would be quite hard to know how severe this storm is. And then I'm gonna finish with this parallax shift image. So I have two images from IR sandwich to illustrate this parallax shift. and it's the shift in the apparent location of a feature due to different viewing angles from a satellite. So if it veers on the right side, it's pretty much in the correct location because it looks from right above the storm. Usually, there is some parallax shift if the storm happens to be at the edge of the imaging swath. But here, the high latitudes, when it's about the geostationary, or when we talk about the geostationary data from Siberi, the parallax shift can be quite big. And here, if you look closely, you can see it's about 50 or 45 kilometers in the wrong place. So that is something that really must be taken into account when doing some nowcasting, that the storms are not in their correct places. But yeah, I thought that it would take a bit longer than this, but I'm finished with this images. And thank you for your interest. And if you have some questions for either me or Anniina, you can ask them now.